Welcome back, students. Today we're going to be talking about solids of revolution. So, when we're dealing with a solid of revolution, what we're talking about is we're starting off with some two-dimensional shape. So, we can all see the rectangles here on the screen. And then we're going to rotate them into the three-dimensional plane around an axis. So, currently, let's go ahead and set this to the x-axis. So I'm going to rotate this line around the x-axis to turn it into a three-dimensional figure. So let's go ahead and watch that. Great. And now we can see that what I formed here is a cylinder. So the cylinder is the solid of revolution of this particular rectangle. Now, this isn't the only shape that I can make with it. If I changed this to the y-axis and then rotated it, well, we got a cylinder again, but we got a very different cylinder this time with very different dimensions than the first. Let's also go ahead and change this a bit, and I'm going to make it so that this cylinder, or that, not even a cylinder anymore, but that this rectangle, I'm now going to rotate it around the y-axis. I want you to imagine in your head what you think is going to happen as this rotates around the y-axis in its full circle and what shape it would create. All right, so now I've created a bit of a wheel with a hole in the middle. Okay, and we could just do it around the x, in which case, no hole, we've just created another cylinder. Now, we can do these kinds of things with a whole bunch of different shapes. Each one is going to cause very different images. So let's go ahead and change this to 2x. We can go ahead and put that back at 0 again. So now think, what's going to happen as it goes around the x-axis? All right, we got a cone. I'm a bit outside of its bounds with that one. That's why it's looking a bit weird. But yeah, we'd get a cone from that. Well, what if we switched it up and did this around that doesn't want to work for me anymore. Let's quickly just refresh. All right, so if I now do it across the y-axis, you'll notice we kind of have a cylinder-looking thing, but with a cone taken out of the top. We could even change that a bit by changing this equation. And now we've got kind of more of a bowl shape. I'm even going to change it a bit more. There we go. There, now it looks even more like a bowl. Okay, but we can get a whole bunch of different shapes from two-dimensional images as we rotate them around an axis. Keep in mind things that happen when your rotation is not directly on the axis. Many times that's going to create holes inside of your shape that you're generating. All right, let's get to the note portion of this. So a solid of revolution is a three-dimensional figure that's formed by rotating a two-dimensional shape around an axis. The line around which the shape is rotated is called an axis of rotation. All right, so let's go ahead and sketch some of these by hand around the axis that they've given us. So we'll know which one is the axis because they've put some arrows there. Now, what I'm going to do to draw this is I'm going to be drawing kind of half circles. So I'm going to take this. So I've drawn this half circle. Now I'm going to continue it past, and I should try and make those about the same length. Same thing there again. Okay. Half circle coming down. Now this one, because I'm just imagining the shape that would be behind, so I'm just going to draw that one as a dotted line, and there I have my cylinder. So this is a cylinder that has height of 9 and a radius of 4. Okay, so now let's rotate this figure. And as it turns out, we've only got one little vertice that's not directly on the line. So we'll just kind of draw our half circle going towards the line. About the same distance after. All right, and now let's finish up that circle. Connect it to the other vertices. And there we have it. We have a, oops, I should have labeled this. This was a cylinder. This one is a cone. And this cone has a radius of 2 and a height of 5. All right, so that's drawing them. Just kind of try to follow that idea of the vertices are points that are not on the line of rotation. Draw a little half circle, and then draw another half circle or part circle that's going that same length before and after. And then complete your circles into these oval shapes, and you can easily draw your own solids of revolution. So now they want us to create a two-dimensional sketch with its axis that would have created a vase like that. So let's go ahead. Let's give ourselves our axis of revolution. There we go. I'm just going to say we start out flat. It comes in, gets wider. You'll notice my artistry is lacking somewhat, but you know what? That's okay for our purposes. Yeah, we got the generalized shape. And if we really want to see how accurate I was, just to laugh at me a bit, let's go ahead and drag that over, see how closely I eyeballed it. Yeah, so got kind of wide there. I was good there, though. Okay, but that's drawing a two-dimensional shape that would match. Okay, and that's essentially what you're doing with those types of problems. All right, so let's get a bit more intense now. We're going to sketch the solid produced by rotating this figure around the given axis. Then we're going to find the surface area and the volume of that three-dimensional figure. All right, so I'm going to draw my little circle, going about the same distance after. Same thing there. Okay, so we would get this cylinder. So we know we have a cylinder that has a radius. Well, let's just go ahead and say we have r equals 6 and a height equal to 8. So let's first do surface area. Now, to find the surface area of a figure, what we're talking about is the area of everything on the outside. Okay, so on the outside of this, I've got a circle at the top. I've got a circle at the bottom. So I've got these two different, just going to put SA for surface area. I've got these two circles that I need to know the area of those circles. Well, the area of a circle is pi r squared, and we have two of them. So I'm going to put 2 pi r squareds plus, now we need to get the side. Well, imagine this was like a soup can. The paper wrapping all around that can is the shape of that. So if you take that paper off, you get a rectangle, right? So there is a rectangle there that we need to know the area of that rectangle. Well, we already know the height of that rectangle, which is going to be an 8, but we also need to know what is that distance around the circle, because that's going to determine how long that paper would be. Well, that's going to be the circumference of the circle, 2 pi r. So we're going to have 2 pi r times h. Okay, and that's going to give us the area of the rectangle around the cylinder. Okay. All right, so now that we've kind of figured out what this equation should be, we can start plugging in numbers. 2 pi plus 2 pi all right. So that's going to give us, let's see, so 36 times 2, so we're going to have 72 pies. Excuse me. Plus 96 pies. Which would then be 168 pi, or approximately 527.79. All right, and now let's think in terms of units. So surface area is done in squares. So this would be units squared. All right, now let's talk volume. An easy way to calculate volume, if you've got a good consistent shape like this, where you've got one single shape that was then simply stretched upwards into 3 dimension. With a lot of shapes, we call those prisms. We can just do the area of the base times by the height. So the volume, the area of the base is the area of a circle, pi r squared, times by the height. So there's our equation for the volume of a cylinder. So we're going to have pi times 6 squared times 8. All right, so the volume is going to be about 288 pi. which is going to be approximately 904.78 units. Now this is volume. It takes place in 3 dimensions, so it's cubed. All right, so this has been part 1. I hope this helps you. Good luck.